our speaker for this workshop, Sujee. Sujee is a seasoned practitioner focusing on generative AI, machine learning, deep learning, big data, distributed systems, and cloud technologies. He also loves teaching and has taught and mentored thousands of professionals. In this workshop, he's going to be focusing on preparing data for LLM applications using Data Prep Kit.
Thank you. Thank you very much. All right, guys. Thank you. So please find a seat. OK, so logistics. My name is Sujee Maniyam. So if you want to take a quick picture, this is the link to the presentation. So I put both QR codes if you have your phone, and if you're on a laptop, bit.ly link here. So maybe take a picture. People ask me, is it like a 1 or a L? This is an L. So, yeah, right, bit.ly, see, L, right? So it is case sensitive if you're typing in the URL on your browser, make sure it's case sensitive. Yeah, right? Anyway, that's a logistic. Take a picture, so this way you have it. All right, so this is a kind of a hybrid workshop. The way I'm going to do this is presentation and a hands-on. You can actually follow along with me. You don't need there's no setup required on your part. We can run everything on Google Colab. So as long as you have a Google account, you can just follow along with me, right? Which I highly recommend, right, if you can. Or otherwise, you can watch it on my screen. Yeah. So, good. So what is this Data Prep Kit? So before I get into this, very quickly, my name is Sujee Maniyam. My areas are basically AI, Gen AI, machine learning, deep learning, whatever we call them these days. I did a lot of data engineering and work in cloud. So that's kind of the toolkit I use. And here's my email. If you have any questions, if you take any pictures or whatever, please send them to me, because I do these workshops and I'm always looking for pictures. so if you happen to take pictures, please email them to me. Yeah, I'll really appreciate it. This is somebody just sent this to me from last workshop. I thought that was a good picture. What this toolkit is about dealing with data. And I'm pretty sure if I say, give me a show of hands, anybody who has done data cleanup, data prep. Actually, let me see a show of hands. How many people can do it day to day, right? Exactly, right? Pretty much all of us do it. And let's be frank, nobody enjoys it, right? Cleaning up data is like the least exciting part of machine learning, right? Let's be frank. So, but we have to do it. Why? Because whether you are building a large language model application or even like a machine learning, right? You need to have good data. So a lot of the times when we start with the data, our data is like in raw format. Maybe you have a bunch of documents, PDFs, Word documents, HTML, right? We cannot feed them directly to the models. So we need to clean them up. And we all kind of do this, and every time we do it, everyone kind of reinvents the same wheel, right? Saying, okay, we'll find some Python modules to do this. We kind of make it work. What Data Prep Kit is basically, think like a Swiss Army knife. It has all these things built in for you. And the first time I found this, I was like, oh man, this is, where was this 5 years ago, right? It would have saved me so much time. Because I did all of this on my own. I'm sure, some of you can relate, right? So Data Prep Kit is basically an open source library. It's been used internally within IBM to train their own models, right? So this is not like some toy project. This is actually being used in large scale, and they're open sourcing it now. So I'm working with IBM, basically, getting the word out, building awareness, right? That's my role in this. So the reason I kind of think like a Swiss Army knife is like, it has like all these things built in, right? So imagine you're going, hiking or camping. We all have one of these, right? So right now, somebody just asked me this. Right now, on Linux and Mac, as we speak, there's a Windows version being released. So it should be online next week or the week after, right? So yeah, don't worry. If you're trying to do it on Windows, it should be available soon. Yeah. And then here's like a little bit more formal diagram, what it can do. So one of the cool things about Data Prep Kit, it can handle both documents and code. So imagine you are training your LLM, right? It can be documents, like a bunch of PDF documents, HTMLs, right, Word documents, what have you. And it can do some pretty cool things. Like, for example, it can actually extract text from PDF. It can extract text from HTML, right? And then it can even eliminate duplicate documents, right? Because, right, when you have a large amount of documents, some of them are going to be duplicates, yeah? And then, yeah, there you go. And then also, it can do like, let's say I'm looking at, say, for example, we want to chunk about, divide the documents into chunks. We'll talk about this a little later. You can do that too. So that's from a document side of things. What if you are dealing with code, right? So same thing, right? So when you're dealing with code, for example, you need to figure out, what sort of a language it is. Is it C++, Java, Python, right? It can do it for you. It can detect the code, the language detection. And also another cool thing, it can actually do scan for viruses, known virus signatures, which is pretty cool, right? Because what if your code, like imagine your code, like hundreds of thousands of code files, what if there's like a little virus file snuck in there, right? You don't want to train your LLM with the virus code, right? Obviously, right? We can imagine the consequences. So the prep kit can scan your code, and it can filter out code that has viruses and things like that, right? Which is pretty cool, I think. Yeah. And we'll talk about this a little bit more, right? So, and another one I want to highlight real quick is PII. So PII stands for personally identifiable information. So imagine you have a bunch of documents with, say, somebody's credit card on them, credit card number, right? Or a social security number. You don't want to feed the data to LLM, right? Because imagine what happens, right? Because LLM learns, and then somebody on the other end can say, okay, what is John's social security number? And the LLM will answer for you, right? Because it learned it from your document. We don't want that. So PI detection, so all these things are pretty important, and all these are actually built in for us, which is pretty cool. Yeah. So it's Python. Yeah, just to reiterate, it's Python. It's open source. It's Apache 2 license. So one of the things I really like is you can start on your laptop. It's Python code, right? It's on your laptop. And as your data grows, you can go to clusters. So it supports 2 cluster modes right now, Ray and Spark. Now, I want to see who actually programs in Ray here. Anyone played with Ray, Python Ray framework? Right? Okay, a couple of hands. Okay, yeah. So Ray is basically a distributed framework. It'll take your Python code and will run on multiple machines, on a cluster. Pretty cool, right? So your plain Python code will run on a cluster. Spark, same thing, right? So I did a lot of work in Spark. Apache Spark is a distributed framework. Basically, you write some code, it'll take your code and run on a cluster. So why do we want to do this? Because, right, on a laptop, we can process certain amount of document, maybe like a few gigabytes, maybe, right? But what if you have hundreds of gigabytes of data? Now your laptop is not going to do it, right? So you actually want a cluster. So this framework, actually, right, this is what I want to highlight. This framework is actually used to train IBM Granite models, right? So IBM has an open source model called Granite. They were just released, a latest version, just this week. So it was trained, used to train the models behind the scenes. So you can imagine the amount of data, right? Terabytes of data, right? Thousands of CPU cores. So this is a well-proven technology that used inside IBM. Yeah. So, all right. So here's what I'm going to do. I'm going to show you some of the features. And for this, you can look at my demo here. And also, you can actually do this on your laptop. So if you have like a laptop, if you're connected to Google Colab, you can actually run this notebook along with me. Right? So it'll be fun. So this way, you actually see it in action. Right? So before this, let me actually show you here. Let me put up this page. All right. So this is the GitHub page with the demo code. I want to make sure you guys have this. So let me put this up here. And yeah. So you can take a picture of this. Right, ups. There we go. Right, bit.ly, and also link. And if you go to this page, this is the code I'm going to run through, and I'm going to demonstrate. Yep. So, and so this is to run this workshop. There's a 2-part series. For part 1, you don't need to do any setup on your laptop. You can run everything on Google Colab, which is great, right? So even if you have Python setup or you don't have Python setup on your laptop, don't worry about it now, right? Just click the link. It'll open the link on Google Colab, and you can run through it. So my goal here is I want to show you what are the features, but I don't want to just show you slides. I actually want to show you code so you can see it in action and kind of appreciate, right, what it's doing for you. Yeah. All right. So everyone's good here. So again, you can follow along with me. So if you're on the GitHub page, if you're going to do this, what I would recommend is, oops, come back, oops. All right. There's a getting ready section. And in this getting ready section, I'm showing you steps what you need to, what you need to run this workshop. Again, like I said, for part one, the first part of the workshop, you don't need to do any setup, right? It completely runs on the cloud. Just click and run. Part two, we recommend you guys have a Python setup locally on your machine, and this will walk you through the steps, right? Again, so you don't need to do it right now, right? I'm just highlighting where things are. Yeah? So again, just follow the instructions, and we actually prioritize open source models, and I actually use Replicate to run open source models in the cloud, right? And the reason I like Replicate is they actually give you free API calls, like a few free API calls per day, which is good, right? So you don't have to put down your credit card. You can just sign up and start using it. And for this workshop, this is more than enough. And actually, I have like a little link here. You can use this link to add some credit to your account. I think it's like $1 or something, right? Don't knock it, because $1 will give you a lot of API calls, right? So yeah, it'll last you a few weeks. So yeah, so why not just add this to your account, right? So yeah, so go ahead and do that. And that is basically where you're getting ready section. That's it. Now, we don't want this to end right out of this workshop. We actually have a Discord server set up for you guys. So you can come and join our Discord server. Like, for example, you're running a workshop on your own, and you run into an issue, right? You can just come to Discord and ask us, right? And we are monitoring them, and the developers are there, other users are there, so you can always get support, right? Again, Discord server, use the link, the invite to join, yeah? So, because we want this to be not just today, right? We want this to be something you continue using and learning. Yeah. For the code, so there are two repos I'm showing, right? This is where the main kit lives, IBM Data Prep Kit, right? So you can, it's open source, you can grab it, Apache 2 license, right? And then if you're running this from the main toolkit, the notebooks are in the examples notebook directory, so just look for that, right? And this is the one I'm showing you right now is my repo, larger, right? This is just examples, right? It doesn't have the core components, right? We are using it as a library. In my repo, I only have examples, right? So that's what I'm going to use here. It's a little smaller repo. You can use it easily. Yeah. All right. So here's what I want to do. I want to start with a workshop, a feature walkthrough, and here you can see, right? I open in Colab. Either one should work, right? I'm going to use mine, option 2, right? So here's, if you're following along, again, let me put this link up one more time. You can take a picture, right? Type the bit.ly. Remember, bit.ly, when you do, it's case sensitive, right? If you're typing it in, make sure it's case sensitive, right? So I want to make sure people are coming in. So let's give it a minute. Yep. Oh yeah, that's right. Yeah, I always do this. Hold on, there we go. Let me get this right. Is it better? Yeah. All right. So yeah, right. So this way, it's GitHub, right? It's always there for us. But I want you to have the link. So if you're doing on your laptop, you can just type in the link, right? So yeah. All right. Here's what we are going to do. We are going to introduce Data Prep Kit. I want to show you some of the features it's going to go in through, and you can walk alongside with me here, right? So I'm going to do option 2 here, right? I'm going to open in Colab, like in right-click, open in Colab, new tab, right? And you can do this along with me if you like. So this way you actually see the code, and I'll explain what the code does. And I'm going to just save some time. I'm going to just get this running, right? I'm going to say runtime, run all. Say run, yeah. Because it takes a while to kind of install some of the dependencies and run. But as it's doing this, I'm going to explain what it's doing. All right, so that is running, right? Again, right? So that's fine. You can just leave it running, right? Yeah. So what are we going to look at here is this. I'm going to show you some of the features. Not all of the features. This is some of the core features. I want to demonstrate what it can do for you. So we're going to look at how to extract text from PDF documents, how to do some cleanup, and how to dedupe, right? Remove duplicates, and finally how to create embeddings, right? That's the plan. So I'm going to show you how easy it is to do all this. Because remember, if anybody done LLM application, I'm sure you remember you've done all this, right? So here, I'm going to show you how the kit can make your life a little easier. Yeah. All right. So let's start with PDF documents, because we probably have PDF documents, a lot of PDF documents, right, in our enterprise, and we want to basically process them. So here I just created 2 simple PDFs, right? The reason I created 2 simple PDFs is I want you guys to sort of see how the data is being extracted. So I don't want like a complex PDF. I just want something simple. But just to get, just to record, set the record, you can process complex PDFs. You can extract data from tables even, right? So it's pretty capable library. But for our demo purposes, I'm just doing a simple PDF, right? So it's like, one Earth, one Mars, right? Very simple PDF, right? All right. So first thing I'm going to do, right? Remember, PDFs, we are going to extract the content. How do we extract the text from PDF? So here you see, right, it's basically extracting information from the PDF, and it's keeping the structure. You can see, right? It kind of says, okay, here you can see, right? So here it says, heading. You can see how it's extracting the heading. It says, yeah, it's a Texas heading. It's a section header. See how it's, right? So it's keeping the structure because that's very important because you don't want to just get plain text from PDF, right? Because then you may lose meaning. You may lose context. You actually want the context also. And here's a paragraph. You can see the one in the green, right? You can come through and then extract the text. It's type paragraph, all right? And look at this bullet point here, right? It's coming up and says, yeah, it says, yeah, type is, it's a list item. Pretty good, right? So it's extracting content while keeping the structure intact, which is very important. Yep. So let's see how this looks in the code, all right? So I'm going to kind of go back to the code. My code is running, remember? So the workflow I'm going to demonstrate is basically this. We are starting with PDF, right? First thing is we're going to extract text from PDF, right? That's the very first step. So let me show you what that looks like. Yeah. And again, I just already ran the code just to save some time, right? We are going to just walk through the code. Yeah. So here's a 2.1. It's a little larger. So this is like a piece of code I use all the time to figure out if I'm running on Colab or not, right? And this saves me a lot of time because in Colab, you had to do things a slightly different way, right? I'm sure you guys know, right? Because Colab, every notebook get their own sandbox, right? So meaning like you had to install libraries and download files and things like this. So Colab needs a little different than running on local. So this way I can actually see if I'm running on Colab or not, right? So pretty handy script. So it says, yeah, running on Colab, right? So as you're running on Colab, you can see I'm downloading some of the files because remember, right, in Colab, every notebook is a sandbox. So we get any input data I need to download. So I'm downloading my input data here, right? That's it. Pretty simple, all right? So it's downloaded here, right? And also I'm seeing if running on Colab, I have to install my libraries. Same deal, right? Because remember, every notebook is a fresh environment. Like if you're running locally, you don't have to do it because if you're running locally, you would have your Python environment set up with all these libraries installed. But in Colab, you don't have the library, so we're installing them, right? That's what's going on. So you can see I'm using the data prep toolkit, right? We are using 2.021 release. Okay. All right, let me scroll through here. All right. So now, I have step by step so I can talk through them. So again, okay. So now I now download my files. I install my Python packages. All right. Now we're actually going to do the transformation, right? So here, I just have basic config, like where's the input coming from, right? Where's the output going, all the usual stuff, right? So yeah, so I'll come back to this one. And all of this is like setting up input-output path. Remember, because we are basically doing a workflow, right? So I'm basically, it's a pipeline. So I'm going to say, okay, what's the first stage of the pipeline, second stage of the pipeline, and so on and so forth. All right, so here's the actual code beginning. Step 4 is called PDF to Parquet. So what we are going to do is we're going to extract text from PDF and basically store the text in a Parquet format. Anyone here work with Parquet format? I'm kind of curious. Yeah, a few hands. Why Parquet? Why not like CSV or JSON or something? Right, Parquet is much more efficient, right? So Parquet is a very compressed, very efficient format for query. And that's why, especially when you have large data, Parquet is a preferred format. Like you will notice that like in large companies, when you have large data, they don't store them in CSV or JSON format, even though they are convenient, right? We store them in Parquet because Parquet is much more efficient for query. Yep. So that's why we are doing it here, right? Because remember, this toolkit is built to scale to terabytes of data. So Parquet is our default choice for data, right? So yeah, so if you're wondering like why Parquet, why not CSV, right? This is why. All right, so let me keep going. All right, so this is my stage 1. So basically the code is this, right? Again, I don't want you guys to get lost in the weed of the code, but basic thing is, right, we are running a PDF to Parquet extractor, right? All it's doing is it's looking at PDF files, going to extract the text into Parquet format, right? That's it. And I'm basically saying, okay, only extract PDF files. Because imagine you have a directory that have mixed files. I have text files, PDF files, Word doc, whatever. I'm saying only care about PDF files. That's what this is saying, right? That's it, right? And you can specify as many file types as you want. As long as they are supported, they will be extracted, right? And I'm basically, mouse, there you go. I'm basically extracting the code and saying, I'm saying launcher run. That's it. I'm saying, okay, kick over the process and go process a bunch of PDFs, right? So it kind of goes and does this, right? And by the way, I don't know if you guys noticed it. You see like a little green thing, right? Anyone know what this is? This green progress bar? It's downloading something, right? It's downloading something. It's actually downloading a model, a deep learning model, to process PDFs. So the way we actually process PDFs, we actually use something called dockling. I don't know if it sees here, right? We use a open source model called dockling, right? It's also an IBM product, open sourced. That's actually a deep learning model. It's been trained on a lot of PDF documents. So when it sees a PDF document, it knows how to extract the content, which is pretty cool, right? But nowhere here I'm specifying dockling, right? I'm just saying, hey, here's a PDF, go process it, right? What is it doing? So it's basically downloading the model on the fly and then using it to, right? And if anybody use Hugging Face models, you'll recognize it, right? We download the models on the fly, and it's the same thing, right? Exact same thing. Anyway, so the first time you run this, right, as you can imagine, it's going to be a little slow, right? Because you download the model, initialize it, do the whole thing, right? But yeah, but the thing is, it'll do it for you. Anyway, so it's done. So now let's inspect the, inspect the file. Sorry, get back. There we go. So let's see what it actually did. Remember, I had two files, right? Earth PDF and Mars PDF, and you can see, right? It basically extracted the content. You can see the content is kind of JSON, like nested format, because it's keeping the structure, right? And also you can see, right, how many pages per document. Are there any tables found? Right? No tables, because in my documents are very simple, right? So it can do all this. So it basically what it has done is it extracted PDF. Here's your content, right? And then also it has metadata, right? And you can see it creating like ID for documents, so it can track it throughout the pipeline, because each document gets a unique ID, right? So yeah. Anyway. All right. So what does this text looks like, right? So again, next step, I'm just printing it out. And if you look at this, right, it's right, again, I'm not going to do the whole thing, but you can see I'm going to hide a few things. You can see, right, here's section header, you can see, and it's, Earth, right? So this is the title. Remember the title Earth came from, right? Earth. And then also it says, font in right, page number 1, B box standing for bounding box, like, what's like the, right, the area, right, around us. So anyway, so again, you don't need to know the internal details. I'm showing you a little bit just so you kind of understand what's going on, right? So why do I keep doing this, right? And that's it, right? And you can sort of scroll down and can see, here's a paragraph, right? It'll extract the bullet points, all that. So it's doing all the work for us. I'm just showing you what it's doing. So the first stage is done. So what's the first stage, right? My first stage is basically extracting, right, PDFs, right? Text from PDF. We just did that, right? So I just did the PDF to, right, to text. First step. Next step, right, we are going to divide the documents into chunks. Now, can somebody tell me why we do this? Like, why do we split the documents into smaller chunks? Right, yep, tokens, yep, very good, very good. Any other guesses? Why we split? And context, right? And also, because remember, right, so imagine this. Imagine my PDF is like 100 pages long. And if I kept the whole 100 pages as basically one unit, my searches are going to be pretty slow, right? Because now I'm searching all 100 pages. Honestly, my query, my answer is going to be in maybe 1 or 2 pages. So I don't need to search all 100 pages to find my answer, right? I just want to search like smaller chunks, right? So the chunks. Now the question is, okay, how do we do chunking? Some people say, let's do page by page. Easy, right? Let's say my PDF has 100 pages, right? I divide them into 100 chunks. Each page is a chunk. Easy enough, yep. Some people might say, oh, what if I do each paragraph is a chunk, right? That's another option, right? So here the chunking is kind of a little smart. It basically kind of looks at what we call natural text boundaries, right? So you can sort of see here, right? you can, and I sort of highlighted here, right? So it keeps the solar system, this paragraph intact, right? Right here, right? That's one chunk. Also, next paragraph, right, it's another chunk. It's doing a paragraph-wise, but you can see it's also keeping the title. So it knows the context, right? So it's not like just extracting paragraph by paragraph. It's also trying to keep the context. That's important. Because when you do query, you kind of want to know, okay, where did this paragraph come from? Oh, yeah, it's part of the solar system, right, heading, right? So it's keeping that as well. So this chunking is what we call natural text boundaries. It works pretty well, and you can configure this, right? If you want to say, page by page, sure, right? We have a setting for that. And you can sort of see like bullet points, right? All this happening. So that kind of makes sense, guys, why we chunk documents. And this is important when you do LLM work, because, like I said, we don't want to search all 100 pages at the same time. Because my search is going to be, 1 or 2 pages, at most, right? That's what I want to chunk them. Any other questions on this one? Yeah. One thing I will point out is chunking itself is a big topic. People have literally done PhDs on trying to figure out what's the best chunking mechanism, right? So when I tell you chunking, so the reason I'm telling you this is, right, yes, there are some common chunking mechanisms, but this is a pretty involved subject, right? So, if you do a search for chunking white papers, right, you'll find like a bunch of papers, right? People actually go, right, spend a lot of time figuring out what's the best chunking mechanism for LLMs, right? So yeah, so just be aware, right? Yeah. Is that a question, guys?
Yeah.
Yeah.
So you said that there are so many methods that have been tried. So which one was the best to maintain the context?
Great question, right? So question was, which one should, basically kind of paraphrase a little bit, which one should I use, right? Which one's the best? So my answer is always the same. The best chunking is the one that works for your documents. It's a little tongue-in-cheek, but let me explain. Because some chunking mechanisms work better for your documents, right? If your documents have a lot of tables, for example, right? In just plain paragraphs, like not a lot of structure, there's a certain chunking that will work. If your PDFs are like basically just text after text, right? Maybe a page-wise chunk should work. So the reason I always say this is I always recommend try out like a couple of chunking mechanisms and see how the performance is, right? Are you getting good results when you do searching, right? And some of them could be a little subjective, right? Because you can say, hey, I did this chunking. How's the result look? Are they looking okay? How much time you're taking, right? And then you'll pick one. So always try a couple of them, right? And then the good news is this: all of these are built in. So you don't have to do this on your own. You just have to change like a little parameter saying, okay, now chunk by paragraph, now chunk by page, whatever, right? Chunk by natural text, whatever. And then run through the pipeline and kind of see the query. Yeah, right. So always remember, and yeah, I get this question all the time. Which chunking is best? And honestly, you have to try a few things to see which one works for you guys. Yeah, great question. Yeah. Any other questions?
What's the chunk size?
It's going to be depending. So here, since I do natural text, it's going to vary, right? So it's not like a fixed size. So what if you have like a long paragraph, right? Then that'll be like one chunk, right? So there are packages that will also help you say, don't chunk, maximum choice is this, right? Don't go beyond that. You can set that too, right? But a lot of the times, you want to do the natural chunking and say how it performs, right? And then usually you get pretty good results. But yeah, you can set the max size too if you want to control that. Yeah.
Because I have a use case where we were trying to process PDF files from courthouses, conversations, arguments that take place in a courthouse.
Right.
And those are just long PDFs with conversations that go on and on for pages and pages altogether.
Right. Yeah.
Now, if you do natural text boundaries on that, you would end up with the entire thing, which you cannot actually give it the entire thing to an LLM. And if you end up splitting them, then the LLM loses context.
Loses context. Yeah. So this is the tricky. So the question is like it's a courthouse conversation, like a Q&A, right? Somebody asks a question, somebody answers. So imagine, right? Q&As can go on forever, right? Pages and pages, right? So at this point, how do you chunk? And this is not a trivial problem, right? You're right. Because if you just do a paragraph, or like a page, it may cut off the context, right? Like the next page might be like just a conversation. You lose the context. So yeah. So let's talk a little bit afterwards. Yeah, I have some ideas I can give you. Yeah. But so again, remember, right? So chunking, there's no like a universally good mechanism. There are all these mechanisms. Just you have to try a few things to see which one works for you guys. Yeah. Great question. Yeah. All right. So how do we do chunking? Okay, let's see that in the code. Again, right? I'm just showing you. So step 5 is where we do chunks, right? So again, let me explain the code real quick. So there's like a module called doc chunk That's it, right? Honestly, I'm running this module. That's it, right? And then basically I'm saying, right, see, I didn't configure anything, right? So it's going with the default parameters. So right now they're doing natural text boundaries, right? And I'm saying, just go ahead and, split that document into chunks. Remember, I had 2 documents, right? I started with 2 documents. So if you look at the output, remember, I started with 2. I ended with 8 chunks, right? So 2 documents became 8, right? So they get split, right? And you can sort of see, right? I'm started 2 and I started with 8. So what this look like? So let me actually show you the code here. Again, I'm printing this out just so you can see how the library is extracting data, right? So you can understand. So if you look at this code, so you can see, right? So earth.pdf, right? Chunk zero is like the first paragraph, right? Our solar system is yada yada yada, right? Second paragraph, right? So more information on solar system, see chapter 1, right? And the next paragraph is another one, right? So you can see it's chunking across text boundaries, right? And then the bullet points, right? That becomes another chunk. So, and this is why I chose a very simple PDF, because you can actually sort of understand how this chunking works. Because when I started using this, I started with the complex PDFs, but I couldn't really understand what's going on, right? I'm like, there are like 100 chunks, like, what's going on, right? So this way, when I see it here, I'm like, I get it, right? I see how they're chunking. So that's what I want to show you guys. So all we are doing here, right, again, sort of recap, what are we doing here? We are basically splitting the document into chunks or segments, right, whatever you want to call them. The reason is we want to search efficiently, and also we want to search within the context, right? That's it. So, and then also master.pdf, you can see, right, I have a bunch of different chunks as well. And you can see here we are doing the natural boundaries, right? So paragraphs and then bullet points become their own. And again, honestly, like if you look at my code, right, again, a lot of this code is just to print out the data, but the actual code, you can see, right, maybe like, 5 lines of code right here. That's it. And it did the work for me. So that's why I want you guys to appreciate this, because, right, if you were, sure you can do this, right, but right, if you have a library to do this for you, right, why not? Just use the library, right? That's why I always say. All right, so chunking is done. Okay. Next step I want to show is dedupe. This is important, right? Because imagine I have documents that are duplicates. And I'm sure, right, if you have thousands of documents or millions of documents, they are bound to be duplicates. We want to eliminate them, right? Because we don't want to feed the duplicate data to LLM, because A, it increases the data size. And B, if anyone comes from machine learning, it does something called overfitting. Right? Because now what overfitting meaning like, this is the same data over and over again, and it kind of biases toward the data, right? We don't want that. We actually want to see, right? So that's why we want to eliminate the duplicate. So here I'm showing a duplicate. There's a text here. You can see the first paragraph on both of these documents is a duplicate, exact same text, right? So I'm going to eliminate one of them. By the way, the duplicate deduction you can do on a per chunk basis or per document basis. I'm just showing either one is fine. I'm just showing the chunk one, just so right, just simple to understand. So what I want to do is I want to say, okay, look at the chunks generated, and we have a dedupe module. It's going to look at the hashes, and I'm going to say, okay, I'm going to remove the ones that are duplicates. Right? Pretty good. So let me show you how this is done. So if you look at the code, you will see, like, right? By the way, the doc ID is basically, remember, right? Before we remove the duplicates, we need to generate the hash ID, right? Because, so the hash is how we identify they are unique, and that's what we are doing right here, right? So the step 6 is basically generating hash, right? It just basically creates a unique ID for each chunks. That's it, right? So, and all we are going to find is, like, I'll skip this because all you're going to have, right? You see like a unique ID generated, right? And that's what we are going to use. So let me go to the next step, step 7, dedupe. Now this dedupe is exact dedupe. What I mean by that is it's going to remove the exact, identical chunks. So when I ran this, you can see, again, the code is right. Again, there's a e-dedupe, right, a module. I'm running this, right? I'm saying, okay, look at the contents column and use this hash ID to compare the chunks, right? Remember, so we don't do text comparison because that's very slow, as you can imagine. We compare hashes, right? And this is pretty standard computer science stuff, right? Especially when you have large documents, doing a text-wise comparison is actually very expensive, right? So we compare hashes, much more effective, all right? Yeah, question.
So you're saying it has to be exact. Could it chunks that are semantically similar?
Yes, yeah, I'm going to show you that in the next section. Yep. So this one, actually, that's a great question. This is exact removal, right? So this is like chunks are exactly the same. We're going to remove this. And this is pretty simple, right? We're going to just compare the hash, same hash, right? Get rid of one. Very simple, right? So that's what we are doing. And so let me show you the output. Again, the code is pretty simple, right? You can see, right, we are setting up the dedupe, and then we are running it. Let me show you the output. That's interesting. See, I started with 8, all right? 8 chunks. Now I'm with 7. 1 is removed. The first paragraph. Remember, the first paragraph is exactly identical on both documents, right? It's removed it. Very good. So I've gone from 8 to 7. Right? So yeah, that's very good. Actually, that's a pretty good idea, right? So this way, I'm removing duplicate chunks. I'm not feeding them into my LLM. Perfect. And all I did was just run like 5 lines of code, right? The rest of the code is just to print out the data. Yeah. So if you look at the output, you'll see, right? Again, you'll see here, right? You'll see our solar system is a vast and fascinating expanse. This will only be available in node 1. So Earth has it. You probably, right? Mars doesn't have it. See, right? Because it's remote. Interesting, right? So this is the exact dedupe. Now there's another one called fuzzy dedupe. This is actually a pretty cool feature, and I'm going to show you this here. Let me explain what that is. And this is what you're asking, right? So yeah. So let's look at these 2 chunks. What do you guys think? Almost the same, right? So not identical, right? Here it says details about our solar system, right? Is this, and the other one says details about the solar system. See chapter 1, right? But semantically, right, they are pretty much the same, right? So and we can remove this, and this is called fuzzy dedupe. Fuzzy, right? Not exact, right? So yeah. So and actually, this module actually has one, right? And the fuzzy dedupe transformation basically looks at the hashes, and the way they look at and say, okay, are they kind of similar, right? And you can tweak the setting to say how aggressive you want it to be. It's like a dial, right? Just like any fuzzy transformation, you can make it very strict, or you can make it very lax. So like a little dial you can tweak to say, okay, yeah, be a little lax, meaning like it'll eliminate more documents. I mean more fuzzy dedupes, or you can make it very strict. Then right, it turns to be comparison to be a little strict. So again, this is a dial you can tweak. Again, what's the right setting for you? Again, I always say, right, try a few settings and see which one works for your documents, right? Because maybe maybe one setting that works for us may not work for you guys, right? So you can again experiment, kind of see which one works for you guys. And this is called fuzzy dedupe, right? You can sort of see here, right, when on the fuzzy dedupe, it's actually eliminated, right, one of the chunks. Pretty cool. Right?
So is it using deep learning?
So, right. So the way they are doing this right now, there's a special hash they generate. It's called min hash, right? And what they do is they calculate the distance between the hashes, right? So if you think about it, right? So the hash for these 2 documents are different, right? They're not the same, but they are very close together because they're almost the same. Right? So what they do is they calculate the distance and say, okay, since these are very very close to each other, one of them must be duplicate. And this is where your parameter comes in. You can say, what's the sort of a minimum distance you want, right? Because if you sort of, give a little bit more leeway, even the hashes that are far apart can be removed, right? That may or may not what you want. But if you sort of dial it down a bit, then the hashes will be really close together, right, to identify, right? Yeah, so this settings, yeah, so they use a hash algorithm, but the smartness is basically they calculate the distance between hashes, right? And then trying to figure out, okay, are they kind of similar? Yeah. All right, so yeah, so basically right now, good question. So question was, which of the one they will eliminate? So right now they can pick any one of these, right? There's a feature we are working on that basically you can prioritize documents. So the higher priority documents, it will keep them, and then remove the duplicate from the lower priority one, right? So right now it's, it can eliminate either one of them, but yeah, pretty soon we will have a priority order. So the higher priority one will be kept, and the lower one will eliminate it. Yeah, exactly. Good question. Good question.
One of them has like a typo or
Right. So again, so if it's like so here you can maybe use a typo or something different, right? So if it's a typo also, it'll figure out. If it's just if the distance is pretty close to each other, it can eliminate, right? Now you can tweak this and say, okay, hey, maybe these are keep them both, right? What you can make is like you can make the comparison a little bit more stricter, so it'll keep them both, right? Yeah. So you're gonna play because there's no like a right setting for all of them. So so I always recommend just play a little bit and see which one comes in. So yeah, you'd always kind of see what it eliminates and then see is this is it a right move for me or not? You can tweak it. Yeah, very good. Yes.
So let's say if these are very similar and one of those gets removed, so how does the model still know that it's common in both of them? I mean, like, the text is present in both of them and that's why it has been removed, right? Because it's a hash and it has a key.
Right. Okay. Yeah. So question was, how do the model knows? But remember, so we are kind of doing this during the cleanup phase, right? So as in so we haven't even sent the data to the model just yet. So right now we are just cleaning up data, right? So the model hasn't seen this. So yeah. So you're right. So model doesn't know it yet, but this is before happening. Before we even feed the data to the model. Yeah. Good question. Right. So question was how do we kind of images? How do we differentiate images? So right now the PDF extractor, right now we don't support images. We support tables, but no images yet. Image support is being worked on. Images are very tricky, right? I see there are people working on this. So the way they are working on the image is they extract the image, right, and then use other deep learning models to say if they are similar images. Right, so that's something you could do. So right now it's not built in just yet, but yeah, so that's what I would recommend. So let's say you want to kind of keep images, right? Yeah, then you use like a sort of vision models to kind of say, hey, I have two images from this PDF. Like, are they similar? Right? Are they exact? Yeah, that's what I would recommend. Yeah, good question. Yeah, because images in PDF is always tricky, right? Yeah, so there are people working on this, and pretty soon you will see, modules coming out. Yeah. Yep. All right, very good. All right. So fuzzy dedupe, right? So this is actually one of my favorite features, right? Because especially with documents, right? Like you said, if you just make a little typo, right, it changes the hash, right? So the actual dedupe may miss it, but it's the same thing, right? So this is really great for eliminating a lot of these typos, and especially when you do OCR scans, like if you're scanning PDF, like handwritten letters, it's scanning OCR, right? Maybe it misidentifies one letter, right? It's the same thing, right? So fuzzy dedupe will catch them. Which is pretty cool. Yeah. So.
Is OCR built in or?
OCR is built in actually, yeah. So thank you. I forgot to mention this. So right now the PDF extractor can support tables. It can also do OCR. When I say OCR, optical character recognition, right? So let's say you have forms like hand filled, right? Like somebody fill up the form, using a handwritten letters, and you scan them, and then when you run the module, they extract the handwritten text. Yeah, that's very good actually. Yeah. So that's what OCR means. So it can do it for you. Yeah, very good. All right, so let me see. What's the question? Okay. Yeah.
How many foreign languages does it?
Good question. Actually, it does. So the question was how many languages it supports. It supports quite I think probably a dozen or so. Right? There's a list. I wish I had the list here, but yeah, it supports all the major languages. Right? So not just English ASCII. It supports more of these. So, and another thing it can do, like let's say you have a mix of documents, like some with English, some in Spanish, some in Japanese, for example, right? It can scan the document and then figure out what language that is, and then apply the models. So it's pretty smart actually. It'll do it for you. So it can recognize languages. So yeah, if you go to the website, they will say these are the supported languages, and then you can see it. Yeah, good question. Thanks for asking. Yeah. All right, guys. All right. So. Yeah.
Kind of similar to that. In terms of languages, one thing I work in is context with cultures and also different dialects and all the nuances that comes with cultural languages across different countries. How does that work? I guess part of this toolkit.
Right.
Kind of assess for that.
Yeah. So great question actually. So question was just repeat. Languages have different nuances, right? Different way they phrase things. Yeah. So the language model, stepping back, the language model is only as good as the data I trained on, right? So let's say we have a language model for English that's trained on a lot of data. Let's say there's a language model for say Japanese that may be not trained on that many data, right? So it's going to be a little less effective, right? So basically what it comes down to is when these models, how well they're trained, each language specific, so they can detect the nuances, right, the dialects and things like this. So I think we are using an open source package that does pretty good job on training, on a large amount of quantity for each language. Again, right, if you go to the website, they will show you what are the languages and also what they support, and then you can see it. Yeah, so that's very important. You're right. For example, if you are, let's say you are passing a lot of, say, documents in, say, in French, right? You want to kind of say how well the language is supported. Yeah, you can see it on the website. Yeah, yeah, yeah. Good, very good. All right, guys. Finally, right? So you kind of right. So remember the diagram here, right? We are kind of, right? We are kind of working our way through. This is our pipeline, right? So we did all this, right? We extracted the text. We split them into chunks. We did the duplicate. We did the fuzzy duplicate, right? So the text is reasonably clean, right? And the final step is creating embeddings, right? So can somebody tell me why do we need embeddings? I'm sure some of you will. Right? Yep. Search. Yep.
Yeah, converting all the text into the vector of numbers.
Right.
That can help to search similar types of images.
Exactly, right? So this is a big deal. I mean, if you do Gen AI models or LLMs, right, embeddings are a big deal. So what embeddings do, let me show you here. Do I have this one? There we go. That's what I'll show you. Okay. So, okay, let me start with the basics. Embeddings is basically converting text into a bunch of numbers. We call them vectors or embeddings, right? Just bunch of numbers, right? That's it. But why is this important? Because computers like numbers, right? So they are much faster searching through numbers than text, right? So that's why we do the conversion. Another reason is when we do the mapping from text to numbers, these are not like random numbers, by the way, right? These numbers actually capture meaning. So how do I mean by that? Is like, so here, right? So take a look at this number. So let's say I am only mapping in two-dimensional, right? X and Y, just for simplicity, right? So when I map a word cat, let's say it maps here, right? I have an X coordinate and Y coordinate, right? Very simple, right? And then I am mapping a word dog. It'll actually map very close to cat. Why is that? Because when the embedding models are like learning through, reading through a lot of text, right? It kind of remembers, yeah, whenever there's a cat mentioned, right, dogs also mentioned, right? So, they are kind of similar together, right? So it kind of learns, okay, you know what, cat and dog, kind of similar together, right? Now, it may not realize they are pets, right? That's a high-level understanding. It may not realize that, but it doesn't have to. All it has to understand is like, hey, whenever you see a word cat and the dog, they're kind of, mentioned in the same context, right? That's it, right? And let's say same thing, rabbit, right? It says, yeah, when I see this animal, they're kind of mentioned in the same context. So I'm going to map them to, pretty close to together, right? Now, it doesn't understand what it means, right? It doesn't understand the meaning of this. It just knows, hey, when I read this bunch of text, whenever I see these words, they're kind of similar together, right? Let's do the other one. Let's say, I'm, also mapping words like banana and apple to here, right? And again, it will say, whenever I read the word banana, right? Banana and apple are mentioned together because they are fruits. Now, it doesn't understand they are fruits. It just knows, they are mentioned kind of close to each other. So when it maps banana, it's not going to map it next to a cat. Right? Because, right, I mean, most likely, right, when you read text, you don't see cat and banana in the same sentence. Hopefully not, right? So it kind of reads, and then so it maps, right? So this inherent knowledge is built in. So how does it know? And people ask me, how does it know? It doesn't know, because the reason, the way it learns is, right, remember there's a model we are using. These models are trained on large amount of text, meaning they read a lot of text, right? So imagine, let's say you are reading, say, let's say you're learning Japanese, you are reading a lot of Japanese text, right? You don't kind of understand the meaning of each word, right? But you say, hey, anytime I see the word, Japanese word for cat, I also see the Japanese word for rabbit, right? That's all you know, right? You don't know what the meaning is. You don't even really understand. It's a pet, right? Just know, hey, these words I kind of see them together a lot. Or you say, when I read the word for banana, I kind of see apples and watermelon, right, close together. I don't know what they are, but I kind of see these words together, right? So that's how these models are. So they don't need to be like super smart, right? Understand the meaning. All they have to know is kind of the association, like where they land. Now, this is pretty good for us because now, right, when we look at these mappings, we can kind of deduce, you know what, hey, maybe, in this segment is pets, because, we know, right, we know they are pets, right? In this segment, they are fruits. Yeah. Pretty good, right? Any question? Yeah.
Yeah, Apple can be like categorized first, but also it can be categorized by like smartphone, Android, Apple, right?
Yep.
So then Apple could be either of those, or is
right? Yeah. Yeah. So yeah, if I said that's a great question, right? So kind of paraphrase. If I said the word Apple, would you guys think like this Apple, or would you guys think like the company Apple? Interesting, right? So that's where the meaning comes in, right? So if I say apple, right, then you'll say, okay, tell me more. Like when you say apple, do you mean like a fruit apple, like I eat apple? Then then we know, okay, it's a fruit, right? Or if you say I love Apple products, then right? Then we know it's a company, right? So at that point, context come into play. Because just the word alone, you're right? Apple can be anything, right? It can be fruit, or it can be the company, right? Who knows, right? Yeah. So then the context come in, exactly. Yeah.
So embedding encounters those contexts altogether. So
yes.
They are not just comparing Apple, the word itself.
Right. Yep. Understand the context. Yes. Yeah. Exactly. Understand the context. Yep. Exactly. So as the models get smarter and smarter, as they read a lot of text, as they train a lot of text, right? They also become aware of the context. Exactly. Yep. Yep. So yeah, very good. Yep. So that's all they map, and basically we can use the intelligence built in. Right. Let me show the next one. So let's say, just to kind of finish embeddings, right? So let's say I'm searching for the word pineapple. Right. Now, so we map the pineapple. So let's say it maps here, right? So I know, okay, pineapple is like, adjacent to fruits, right? It's not adjacent to pets, right? So when you do a search for pineapple, I may also get the search results for apple and banana. Interesting. And so this is what we call context searches, or more like meaningful searches. You can do this right now. Go to Google Maps and search for the word donut, right? So they will give you donut shops and ice cream shops, right? Other dessert shops. And you're wondering, I just searched for donut. Why are they showing me ice cream shops? That doesn't sell donuts, all right? Because it's context, right? Because I search for pineapple. Maybe there are no pineapple shops near me, but maybe they are the same context. I'm showing you, shops that are selling apple. I search for donuts, right? There are no donut shops nearby, but donuts are categorized as desserts. So maybe you're in the mood for a dessert, and maybe I'll show you some like a boba place or a bakery, right? And you can do it right now. You go to Google Maps and do a search, and you will see it, right? So what they're doing is they're basically showing what you call vector search, not keyword search. Right? Keyword search is what we know all about, right? Just search for a particular keyword, not very exciting. Vector search or semantic search is meaning. So if I do a search for donut, they kind of know just because where the donut is placed, okay, maybe I'm looking for fruits or desserts, and they're showing me desert places. All right? Anyway, so how is it enabled? Because remember, so you kind of go back to the basic, right? The way we can do this, because we map them to embeddings, and the embeddings models are learned, right? They read a lot of text. That's how they're trained. So they pick up the meaning of this word, right? Pick up the context of the word. They map them, and then when we map them, and then when you do the query, we can get this closest neighbors. Pretty good, right? So kind of yeah, yes.
Does embedding company specific, like LLM, like OpenAI, Gemini, have different embedding, or
Yeah.
would it be compatible?
Good question. So question was like like different embedding models. So yeah, so there are so many different embedding models, right? Some of them are open source, some of them are proprietary. Like the one from OpenAI, you can only access them using API, right? It's not open, but there are a lot of open models available. So technically, embedding models and LLMs are two separate entities, right? However, in practice, some embeddings work well with some models, right? So if you're using OpenAI for your query, it's probably best to use the own embedding, right? Because it's kind of really optimized for that. So even though technically they're like two separate things, right? It's kind of like, right? Kind of like you're getting a dessert, right? So let's say you want to get in the mood for coffee, right? Do you want to get coffee and boba? I don't know, maybe not. Maybe coffee and donut? Maybe, right? so technically separate, but they go together, right? I'm a big fan of a lot of open source embedding models. Actually, the data prep kit supports, you can plug in any open source embedding model, and they will use it for you, right? Because the open source embedding models are actually pretty good these days. They actually code up quite a lot in the last few years, and you get pretty good results by using open source models. Yeah. All right, let me show you the code real quick. Yep. So for the timing is good. Okay, so now I want to generate embeddings. Yep. All right. So here's how it looks like, right? So we are going to, remember we split the document into chunks, right? We already went through that. And then we also eliminated duplicate chunks, did the fuzzy dedupe. So my text is now very clean, right? Now it's time for us to convert them to embeddings, right? This is the final step, right? So basically, we are taking the chunks and converting them into basically vectors, embeddings, right? So, and this is built in, right? So this is very, very straightforward. Let me show you real quick. Yeah. I think this is the last step we have. All right. Embedding. By the way, in the fuzzy dedupe, I just want to show you something real quick. When I did the fuzzy dedupe, right, I started with 7 documents, I ended with 6. So, one removed with fuzzy, right? Just, remember, right? These are like not exactly the same, but similar, right? Remove. All right. That was from the last one. Okay, so embedding model is very simple, right? So here, step 9, I'm basically specifying what's the embedding model I'm using. Again, what's the model I'm using? Let me go see. I think I'm using mini LLM. There we go, right? Mini LLM, pretty decent model, right? Open source. So what my program will do is it'll basically download it from Hugging Face. You can see it, right? You can see like a progress bar at the bottom, right? Yeah, and then it'll download and embed it. And all it does is at the end, right? If you see the output, you'll see, right, at the end, see embeddings. Each chunk is converted into a bunch of vectors. Already built in. So you can plug in your own model, right? Again, we support, right, pretty much all the open source ones. Just plug them in, and then, yeah, right? So easy. So here I've shown you a few features, right? You can see, and again, I just, I didn't have to set up my own computer. I just ran everything on Colab. So you can run this along, experiment. And there were a couple of questions about embedding models. So if you do a search for embedding leaderboard, excuse me, you'll go to a Hugging Face page that lists the embeddings, right? So which one do you use? It depends. Like for example, look at this one, right? Mistral. And by the way, this is the screenshot I took maybe like a month ago. If you go there now, it's going to be different because it changes daily, right? As new models come online, they run the test, and they do the scoring, right? They do the scoring, the score. It will keep changing as well. So by the time I took the screenshot, the highest score like 66. I think now they are probably like 70s, right? Because remember, the models improve too, right? So as models improve, they get higher and higher. So take a look at this one, right? Mistral model, this Mistral 7 billion parameters, it's a pretty big model, right? It's the highest scoring model back then. It scored 66, right, in all the benchmarks, right? Look at the size though, 15 gig, right? So it's a pretty hefty model, right? And then it has 7 billion parameters. And also it creates 4,096 vectors for every time you encode something, you end up getting 4,096 numbers. So pretty big vector, right? And also pretty accurate, right? And that's why they are scoring pretty high, right? Look at the next one down, right? This is BG large, right? Next one down is scoring, score go from 66 to 64, 2-point drop, right? But look at the size drop. I go from 15 gig to basically 1.5 gig, right? Like basically 10 times less, right? And this one has 7 billion parameters. This one only has 300 or so million parameters, right? Much smaller model, right? So, and then it generates about 1,024 embeddings. So you can go and say, if you really want the top of the line embedding, right, you're going to pick the big models, right? And they're going to be pretty hefty to run, right? You need like a good GPUs and everything to run. Or you can say, I'm going to go like the second model, the third model, right? That's much smaller. That's still, right? Gives you a reasonable performance, right? It's not a bad, right? Not a bad drop, 2 points. Maybe that's important, maybe it's not, right? So yeah, so the reason I always show this is there's no a right embedding. There's a lot of the time you're going to look at the performance, right? And the size and everything. Because remember, the larger models take a lot of time to run, right? You need GPUs most likely to run them effectively. So yeah, right? So if you sort of work down the way, right, which one I'm using? Oh yeah, this is me, right? Mini LLM, this is what I'm using. 56, right? So I'm getting like a 10-point drop from the top score, right? But it's a much smaller model, right? Only 134 megabyte. Yeah. So anyway, right? So choice is yours. You can basically plug in any of the open source models, and we will download them and plug them in, right? So yeah. So go to embedding model leaderboard, and you'll see it will change daily, right? Yeah. So a lot of the time people ask me which one should I use. Again, so depending on your use case, like for example, if you're using OpenAI a lot, maybe use their own embedding, right? Because you're already in the ecosystem. Use the OpenAI embedding model. Let's say you're using Mistral, maybe use theirs. If you're open source, there are plenty of open source models. I go to the leaderboard. So usually what I do is I go to the leaderboard, like look at the top performers, look at the open source ones, and try a few, right? You can plug them very easily, kind of see how the performance is, right? So I kind of want to like choose like the something small, but still gives me good performance, right? So it's easy to run, doesn't take a lot of resources, a lot of laptop, a lot of CPU, GPU, right? So that's what I look for.